Question number 9. The year is May 2023. It says A, L, M, N, and R are points on the circumference of a circle with center O. PQ is a tangent to the circle at R. Angle PRL is 48 degrees. Angle RON is equal to 156 degrees. We're asked to find the value of each of the following angles, given reasons for each of your answer. Show all working where appropriate. The first angle is angle R. The first angle is angle R. Now, angle R is equal to 156 divided by 2. It's equal to 78 degrees. And the basic reason for that is that the angle at the center is that the angle at center, which is angle RON, is 2 times the angle at the circumference, is 2 times the angle at the circumference. And of course, the angle at the circumference is R. So how do I identify these? So in other words, if the angle at the center is 2 times the angle at the circumference, it means that the angle at the circumference is a half the angle at the center. The angle at the center is angle RON, it's 156 degrees. So how do we identify them? The angle at the center and the angle at the circumference both start and end at the same point on the circumference. So they both start at R and they both end at N. But one goes to the center of the circle, RON, and one goes to the circumference, RLN. So they both start and end at L. One goes to the center, one goes to the circumference. The angle at the center is 2 times the angle at the circumference. Angle E. Now, angle E is equal to angle R. Angle E is equal to angle R, which is equal to 78 degrees. And the reason for that is this. Angle E is called the angle between the chord and the tangent at the point of contact. The angle between the chord and the tangent at the point of contact, which is angle E, is equal to the angle in the alternate segment, which is angle R. So it's coming from this rule. This rule. The angle between the tangent and the chord at the point of contact is equal to the angle in the alternate segment. So that is the rule. So I can say that angle E is equal to angle R. They're both equal to 78 degrees. And let's write the reason. So the angle between the tangent and the chord at the point of contact is E, and that is equal to angle R, which is the angle in the alternate segment, A. So angle A is there. That's the best way to go about finding A. I guess I could always find this angle, which is angle NRL. So angle NRL. So sometimes it requires a little work, is equal to 180 degrees minus 48 plus E, which is 78 degrees, which is equal to 180 minus 48 plus 78 is equal to 180 minus 126 degrees is equal to 54 degrees. All right, so this angle here is 54 degrees. Now, LMNR is what you call a cyclic quadrilateral. All four vertices, L, M, N, and R, are touching the circumference, therefore it's called a cyclic quadrilateral. And opposite angles in a cyclic quadrilateral are supplementary, meaning that they add up to 180 degrees. So I can say that angle A is equal to 180 minus 54 degrees, which is equal to 126 degrees. They are opposite angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are supplementary. All right, let's go for the B part of the question. In the B part of the question, we're told that the diagram below shows a triangular field, L, M, P on horizontal ground. We're to calculate the value of angle MLP. So that's this angle here. We're to calculate the value of this angle. All right, so we have a triangle. It's a non-right angle triangle, and we have the lengths of all three sides. If you have a non-right angle triangle, you know the length of all three sides, and you're asked to find the size of one of the interior angles, you must use the cosine rule. So the cosine rule is C squared is equal to A squared plus B squared minus 2AB cosine C. So for my formula, this would be little c. This would be big C, the angle, and these two would be A and B respectively. So C is the side that is opposite the angle that you want to find. Big C is the angle that you want to find, which is theta in this case. A and B are the other two sides. So this is 180 degrees, 180 square is equal to 120 square plus 150 square minus 2 times 120 times 150, the cosine of the angle that we don't know, which is theta. Working this out, we have 32,400 400 is equal to 14,400 plus 22,500 minus 36,000. All right, don't be afraid of the big numbers. Cos theta. My objective is to find out what is theta. Bring in 36,000 cos theta to the left to make it positive, and over to the right, add 14,400 and 22,500 to get 36,900 minus the 32,400, and we end up with cos theta being 4,500 divided by 36,000. Cancel that. So now we have theta is equal to cos inverse. So if you know the cosine of an angle, to find the angle, you must use cosine inverse. 45 over 360. And this angle theta, which is angle MLP, is equal to 82.8 degrees. What else do they want to know? They want to know the bearing of P from L. They want to know the bearing of P from L. So we're taking a bearing from L. It's the bearing of P from L. Bearing is always measured clockwise. So that's it. So that angle there represents the bearing of P from L. We can clearly see that it is more than 180 degrees. All right, how are we going to find it? So let's find out. We want that angle. We're also told that the bearing of P from L is 210 degrees. So this is 210 degrees. All right, so they were telling us that. And we are to find the bearing of M from L. We're to find the bearing of M from L. Bearing of P from L is 210. I want the bearing of M from L. I want the bearing of M from L. Is there anything else that we knew? No. Let's get back to it. All right, so here's what we know. Well, we could find this angle here. Let's change our color a little. We could find this angle here, which is equal to 360 minus 210. So this would be 150 degrees. All right. Now, the bearing of M from L is this angle here. The angle here in the middle is 82.8 degrees. So we could say roughly 83. Let's put 82.8 degrees. So with that, now we should be able to determine the bearing of L from N. So the bearing of L from L. All right, let's call this angle here alpha. And we could say that alpha is equal to 360 minus 210, which is 150 degrees. Now, the bearing of M from L, that angle would be equal to 360 minus 150 plus 82.8 degrees. This is equal to 360 minus 232.8. And this is approximately 127 degrees. The bearing of M from L, that's this red line here, is 127 degrees. That red arc there is 127 degrees. Lastly, we're asked to calculate the angle, the value of angle NLP. Angle NLP. Angle NLP. All right, the only N I'm seeing there is the north. So NLP, wonder which one they want. NLP, you could go two directions. You could go NLP this way or NLP the other way. No, it says calculate the value of angle NLP and hence the bearing of what? L from P. The bearing of L from P. Angle NLP. If we're looking at the outside one, all right, let's make it the inside one. Angle NLP would be equal to 200 and what? Angle N so let's go again what they want. They want the bearing of L from P. The bearing of L from P. So we're taking a bearing from P now. All right, this is my north-south line. It's the bearing of L from P. So bearing is measured clockwise from north, so I need that angle. All right, we already calculated this angle to be 150. These two angles are co-interior angle. That's this angle here and this angle here. They're co-interior angles, and co-interior angles add up to what? 180 degrees. So I can say angle NLP is 360, because I said we calculated it already, minus 210, which is 150 degrees. And the bearing of L from P is equal to 180 minus 150. This is equal to bearing of L from P is equal to 030, is equal to 30 degrees. All right.